This is IPitomy training for the IPitomy IP PBX. This session covers trunks and the installation of each trunk type. Installing trunks onto the IPitomy IP PBX is accomplished using hardware or software or both. Analog serial lines, which are loosely referred to as trunks, are connected either by analog serial line interface boards or by using a gateway. Digital trunks such as PRI are installed using digital trunk interface boards, while SIP, Session Initiation Protocol trunks, are installed by software registration alone. In this video, we're going to start with analog trunks using hardware boards. PSTN POTS lines or CO lines are connected to your IPitomy IP PBX using Digium hardware boards. These are available from IPitomy in 4, 8, 16, or 24 port configurations. It is rare, though, that 16 or 24 port cards are sold, since it is usually much more cost-effective to deploy PRI digital trunks for high circuit capacities. Digital is always the desired trunk method regardless of capacity, since broad range of features and better performance are possible with digital connections. The analog boards shown are the 4-port and 16-port boards. Note that the 16 and 24-port boards can only be installed into the IP2000 and IP5000 chassis. The 4-port board shown is installed in the IP1200 PBX. This and the 8-port board can be installed in any IPitomy PBX chassis. If you ordered your IPitomy PBX with an analog board, it is installed for you at IPitomy before it ships. If you're upgrading an IP1100 or 1200, please refer to the hardware board installation procedure later in this video that discusses PRI board installation, as the physical installation process is the same. Once the board is installed, it must be programmed into the PBX. Open the PBX GUI and navigate to the Providers Hardware Trunks page. Under the heading Model, select TDM808B from the list for either the 4 or 8-port board. When installing the 16-port or 24-port board into the IP2000 or 5000, select TDM2404B or TDM2406B, respectively. Click on Set to create the presence of the board in the PBX database, and then click on Add Lines. Input a name for this group of lines. The name will appear in several locations in the PBX GUI for setup purposes. I'm going to call this one Analog Lines. Set signaling type to FXS KS. Set answer incoming to yes. Set start channel to the first position on the board that will have dial tone connected. Typically this will be 1 for port 1. Set answer after to 2. Since caller ID is received just before the second ring on analog circuits, this allows the PBX to collect caller ID digits prior to answering the call. Set end channel to the highest port number that is connected to dial tone. If you have an 8-port card but will use only 6 CO lines, set this to 6. Click on Save Changes and then click on Apply Changes. When this is complete, go back to the Providers Hardware page, scroll to the bottom and click on Restart USB Devices and PBX Services. This will load the PBX services that you've just created. Note that this will also stop all calls in progress, so if you're doing this on a live active system, wait for the appropriate time to click this button. Also note this button is provided on the Providers Hardware page for convenience. When the operation is complete, you will find yourself on the PBX Setup Services page, since this is where the actual function resides. Under System Functions, restart all services. Routing will be covered in the next video, but we'll briefly look now to familiarize you with what's needed next in deploying trunks. Navigate to Call Routing Incoming. Notice that the trunk group that you've just programmed is located in the table of trunks listed on the page. The pull-down indicates None. This is the destination set for this trunk group on ringing. It's important to note that although the specific trunk group has no programming, ringing on these trunks will be directed to a default destination. This is seen under Default Incoming Destination. In this case, calls on these trunks will route to the automated attendant. We can select a destination for this trunk group specifically by selecting it from the many options available. To save the changes made here, click on Save Changes before moving on to another page. Now we'll look at call routing outgoing. I'll select one route for this example, 10-digit dialing. On this system, there is already a route option for this dialing pattern, but since we're installing our new trunks, click on the pull-down next to the Add button, and the new trunk group will appear on the list. Select the new group from the list and then click Add. The group is added to the list of available trunks to use when this digit pattern is dialed. Notice though that it is listed second to the one that previously existed. To move the group up in order so that it is selected first for calls with this digit pattern, click on the trunk group in the Available Trunks box and then click on the Up button. This will reposition the trunk group as the one to select before any others below it. Click on Save Changes to save this page. Since I'm done programming, I'll click on Apply Changes to make all of the changes. When we clicked on the Restart PBX Services button, the LEDs on the analog card we installed turned on to indicate that they are recognized by the PBX. Notice that I have only one CO line connected. Another option for connecting CO lines to the IPitomy IP PBX is to use a gateway. A CO line gateway converts a CO line or analog trunk into a digital signal that can be used on the IPitomy PBX. There are two gateways available, a 4-port and an 8-port. To program the GrandStream gateway, you must first connect the GrandStream gateway to the LAN. Pay attention to connect the gateway to the LAN using the gateway WAN port. The WAN port of the gateway should be connected to one of the available QoS-capable switch ports. Now find the GrandStream on the LAN. This is easily done on newer versions of the IPitomy PBX since the PBX now includes a network scanning utility. Navigate to Diagnostics Network, then click on Network Scan. Input the local area network IP address using CIDR notation so that the subnet desired is fully scanned. In a typical generic subnet, the input required would be 192.168.1.0/24. Use this example to determine the input required for your specific subnet. Then click Scan. All the devices on the subnet selected will be displayed in the result. Find the GrandStream gateway on the list. If there are multiple gateways, you will need to confirm the gateway desired using its MAC address. Note that the IP address on the list is a link and can be clicked to open a new browser tab or window to access that GrandStream. When the GrandStream GUI is open, input the GrandStream default password, which is admin, all lowercase. It's probably not necessary to change this password since the device is located on the LAN and not addressable from the WAN. Navigate to the Basic Settings page. Assign a static IP address to the gateway by selecting Statically Configured and inputting the IP address to be used for this gateway. When assigning the static IP address of the gateway, be sure to select an address that is not part of the DHCP pool. Check the DHCP pool range before selecting an IP address. It is also important to select an IP address that is not statically assigned to another network device. Set the subnet mask, which is usually 255.255.255.0. Then set the default router. This will be the router to which the PBX is also directed, usually 192.168.1.1. Then set the DNS server 1 and 2 to the same IP address as the router or to the same DNS that is programmed into the router. Click on Update. You will be prompted to reboot, but don't since we need to make more changes first. Now navigate to the FXO lines page. Change stage method from the default 2 to 1 for all channels. Be careful to match the syntax exactly. The date in this field should be CH1-4:1. Now configure the data parameter, channel dialing into VoIP, unconditional call forward, user ID. Use this field to identify the gateway port that is ringing into the PBX. Change the default to the following string: CH1:1111, CH2:2222, CH3:3333, CH4:4444. These 4-digit codes will fill the DID data field of the SIP packet being sent to the PBX and allow incoming routing specifically to the line attached to the port. The line attached to channel 1 will send DID number 1111, channel 2 2222, etc. The next data parameter, SIP server, can be defined for each port. It points to a profile that we'll program soon. Usually only one profile is needed, so we'll leave this field as is, which points all ports to profile 1. The last thing to mention on this page is silence timeout. This setting determines when a call that has no voice traffic should be considered inactive and automatically disconnected. This can cause problems on poor quality analog connections, so we like to adjust this time to a very long period. Set this parameter to 3600 seconds. Click Update on this page to save it. Then navigate to Profile 1. Input a name to identify this profile. Set the SIP server to the LAN IP address of the IPitomy PBX. Set SIP registration to No. Then click Update. Navigate to Dial Plan. In PSTN outgoing call dial plan, input the exact string bracket X plus space pipe space square bracket X asterisk end square bracket plus end bracket. Note that the pipe is a pipe character, not the digit 1. If the pound digit is also desired as a first digit dialed, it too must be programmed. In this case, the string would be bracket X plus space pipe space open square brackets X asterisk end square bracket plus space pipe space open square bracket X pound end square bracket plus end bracket. Click Update. At this point, the required programming is complete. To make this programming operational in the Grand Stream, click Reboot. The Grand Stream will reboot and will no longer respond to the DHCP IP address where it was first discovered because we changed the IP address to a static IP address. To navigate to the Grand Stream again, it is necessary to use that IP address. Now the gateway trunks must be programmed for access in the PBX. Navigate to Providers, SIP Providers. Click Add Provider. Input a name for this provider. I'm calling mine Grand Stream to keep it simple. If there are more than one Grand Stream installed, you may wish to name each differently, Grand Stream 1 and Grand Stream 2, etc. Set user type to peer. Set the host to the IP address of the Grand Stream. Set register to no. Set authentication to no. Set call limit to the number of CO lines that are attached to the Grand Stream. Set the default destination. If you leave this blank, the incoming routing default destination will be referenced for these lines. Input the DID numbers that we set up in the Grand Stream, 1111, 2222, etc. Select a specific destination for each of these lines if desired. Click Save Changes, and then click Apply Changes. When using analog lines, it's very important to assure that these lines have the correct electrical properties. We found a website where many helpful tidbits can be found. It's www.sandman.com. We have derived the chart you see here from the information we collected from this site. We suggest you adhere to these practices outlined on sandman.com and take measurements of the CO line conditions to assure that they perform at their peak. PRI trunks are a high-quality trunk option that is time-tested. We recommend digital trunks whenever possible, and PRI is the best choice when bandwidth is insufficient for adequate use of SIP trunks. PRI is primary rate interface, digital, guaranteed service, and often supports features associated with IP telephony implementations. Check the carrier to see what is possible. Typically, the PRI card is installed at IPitomy before it ships. We'll cover the installation of a card in the event you must do the procedure. If you are upgrading an IP 1100, you will first have to install the bus riser and bus extender. The current hardware model IP 1100 can be upgraded to an IP 1200 and equipped with the necessary hardware to install one PRI board. The following steps are required to complete this upgrade. Obtain a bus riser, a bus extender, hardware license, and the PRI board. T110P for a single port or TE122P for dual port. Then, open the server chassis, install the hardware, upgrade the system license, and program the board. When the interior of the IP 1100 is exposed, you will see one expansion slot available on the motherboard. Follow the steps to upgrade the IP1100. First, power down the PBX server, remove the cover, remove the expansion slot cover plate from the back side of the server, install the bus riser, and then attach the bus extender to the PRI board that's being installed. Position the PRI into the open slot and align it and the bus extender into the 90-degree angle riser. Apply slight pressure to insert the PRI board and bus extender into the bus riser connector. Reposition and replace the screws for the server cover. If you are upgrading an IP1200 with a PRI board, the bus riser and bus extender are already in place. The steps are very similar to those we've already covered. You will need to obtain a hardware license and a PRI board. Open the server chassis, install the board, upgrade the system license, and program and configure the board. Once the PRI board is installed, it must be configured in the PBX. First, collect the information about the interface from the service provider, usually called the LBO or line build-out. The information should include what switch type is used, what dial plan, what is the framing and coding, will the provider be configured as the primary timing source, what channels are going to be used for calling, and a number for technical assistance for the carrier before you prepare for the cutover. Once the PRI is installed and the PBX power is restored, you are ready to navigate to the PBX and begin configuring your PRI card. In the PBX GUI, navigate to Providers, Hardware Trunks. For the card being programmed, select Model. I'm selecting T110P since I've installed a board with a single PRI interface. For the dual port PRI, select TE205P. Then click Set. The information for the span will appear. Using the information you've received from the service provider, match the fields under T1 span configuration and T1 PRI span configuration. Be sure to indicate the channel that will be used as the data channel, or D channel. This is usually channel 24. Click on Set for both of these programming categories. Then click Add Lines to program the specific PRI characteristics. Give the trunk group a name. Then enter the start and end channels to reflect the channels to be used for voice. Set the signaling type to PRI_CPE unless otherwise specified by the provider. Allow caller to transfer an outgoing call should typically be enabled, since this will allow a user to make an outbound call, then park or transfer that call. The rest of this page can be left at defaulted values or configured as needed. I have input a few DID numbers as examples. My numbers are 10 digits in length, but DID numbers can be 4, 7, or 10 digits. You must know what your service provider is sending on this PRI to properly program DID numbers. Once the DID numbers are programmed, I can direct them to a specific destination. Note that I can click on Set to set the destination and that the others remain unassigned. Note that any DID number that is not assigned will follow the incoming destination programmed as the destination for this trunk group. In fact, DID numbers not listed will also follow the trunk group destination. When you're finished on this page, click Save Changes. When you're finished with all of your programming changes, click Apply Changes. Now return to the Provider's Hardware Trunk page and click on Reset USB Devices and PBX Services to launch this hardware function. When the PRI card is installed and programmed, the link lamp will light green when it is attached to the service provider or to a loopback tester. A flashing red lamp indicates trouble. SIP trunks are the other digital option for trunks. SIP trunks can outperform PRI, but the WAN service, usually the internet, must be adequate bandwidth for this connection. SIP trunks are often exceptionally economical compared to other trunk options, and since IPitomy is entirely digital, SIP are spatially ubiquitous. That means you can expand them as you need with no concern for hardware limitations. When installing SIP trunks, get a SIP configuration from the service provider. Sometimes this is referred to as an asterisk configuration. In my example, I'm using AirSpring. Navigate to Providers, SIP Providers, input a name for this trunk, set the parameters according to what was received from your provider, usually in an introduction email. The host is the location where the IPitomy PBX connects to the provider. It could be a domain name or a specific IP address. Registered connections require a username and password. In this case, the authentication of the connection is maintained by the IP address of the PBX WAN connection. Be sure to set the call limit according to the subscription for the service. As the past examples, I am putting a couple of DID numbers in, which can then be directed independently. A list of SIP providers that are interoperability tested on the IPitomy PBX can be found on our wiki at wiki.ipitomy.com. Do a search for SIP configuration. When searching the wiki, be sure to click on the search button for the most results. Using the Enter key or clicking on the Go button will result in only the page with the closest match to be displayed. If you're using the access control list, be sure that you input the host into that access control list or this SIP provider will not function. In the access control list, it's possible to input either the IP address or the domain name. That concludes the programming of all trunk types in the IPitomy PBX. The next session will expand on the routing of calls.